Okay, so let me rephrase once again just for recording. So here access modifiers, here we have 4: public, private, protected, internal, and we can apply them on top of your class and class members. We'll see. We haven't started anything yet. So we are talking about visibility for within assembly or across assemblies. Assembly is nothing but a project, right? And we have created 2 projects, AM1 sample and AM2 sample here, right? Now what we're going to do, we are going to refer AM1 into AM2. Now how to do that? Right click and say add reference, and here you can see in my AM2 I'm going to select my AM1 across solution projects, right? You have different options to select. Either you can browse, if you have a separate library from anywhere, you can browse and select, right? And if you want to select from a local machine installed assemblies of .NET, you can always go back here. You can see, right? You can select from one of the .NET libraries, anything. So I'm going to select my project called AM1 sample. Click on OK. Now you can see this reference of AM1 sample, the binary of AM1 sample got added. Now AM2 is using AM1, right? And AM1, which is my main project, is a separate project. There is no relation between AM1 when I stand at AM1. But when I stand at AM2, AM2 is using my AM1 sample. Simple as that. So now let's do one thing. In AM1 sample, first let's see that, so these are the 2 assemblies we created, and we have a related assemblies here. Now let's get back. So now let's see how different entities work with the visibility. Now first let's talk about class. So when we're talking about a class have got 2 access modifiers, one public, second internal. That's it. It doesn't have internal. It doesn't have all 4 access modifiers. It have got 2 access modifiers. And internal is a default one. If you don't define any access modifier to class, then it will take internal as a default. Now first let's see what is internal, and then let's come to public. Okay. So first let's create a simple class. If you remember, whenever we create any class, right? Let me right click on this AM1 sample and say add a class. So let me call it as class 1 in AM1 sample. Click on add. So now you can see this is my AM1 sample. Let me just keep it here. I'm keeping all my AM1 samples in one slot, right? You can see class 1, right, doesn't have access modifier. So if it doesn't have any access modifier, then it is by default internal. Now what is the meaning of internal? Meaning of internal is any class defined internal can be accessed only within assembly. Right? Now this is accessed only within assembly. When we say within assembly, which means within the same project only, I can have visibility of class 1 only in AM1 sample. So let's look at it. In my program.cs, let's go and say class 1. See, I'm getting class 1. Let's say I'm going to create obj is equal to new object. Right? Now similarly, let's go back here, which is my AM2, and try to access. Now before I try to access, what is important? This is my library added. So what I have to do? I have to call using AM1 sample. See, this AM1 sample we are using in AM2 sample. AM2 is my separate project, right? And it's obvious that if I'm using system, if you remember system, this is a library we have added and we were using it, right? It is not just you have to add, you also have to import it or use it. Similarly, AM1 sample we have added as a reference and we are using it here. Now here, whatever are exposed classes or anything will be used. So here you can see when I start typing in class 1 is not coming, which means class 1 is not available or visible to cross assembly. Why? Because class 1 is internal. Either you give it, if you don't give any access modifier, then it is internal, or you can actually mention internal also. See, you can mention it as internal. Both are same. Doesn't matter. Let me just rebuild it. Right. So now we created a class 1 with internal access modifier. Right. So when you go back to program.css, you are still able to access in the same project. But when I go back here, you can see my class 1 is not yet ready. Okay. Now let's come back to public. What is public? Now public will give accessibility across and within both. So it has visibility everywhere, kind of. Right? Now here, let me make this class as public. As soon as I make this public and save, see when you save it, it automatically, right, internally with the minor changes, it is going to build up the project. That's what happens. Go back to program. First thing, when I say public, I said it is accessible everywhere. When I say everywhere, which means all the classes or this class which is public, first thing within project, yes, I will be able to access. And across projects, now let us see across projects. Now we have created class 1 public. Let's try whether I'm able to access this in my second project. You can see when I say class 1, yes, I'm able to access. Simple. So now it's perfect. Now which means when you have a class public, right, then you will be able to access that class across your projects. That is how class visibility can be created using a public and internal. Now these two are the access modifiers which can be used for class entity. Right? Now let's go to the next one, which is a class member. Now,
Srinath, I just have a doubt. Yes, we can use a class as private also. We can declare a class as private too, right?
I'm sorry?
The access modifier private can be used right before the class, right?
So you mean to say here you are talking about private here?
Yeah.
See, I'll tell you what. When you are creating a class private, right? First, let's see. Is there any use of creating private class? I mean,
no, but it accepts, right?
It will not accept. You can see elements defined namespace not basically defined as private, protected, or protected internal. You're not supposed to do that. See, maybe you're talking about the methods and variables. We're coming to that actually. I hope you're not talking about a class, because class, right, you are not supposed to define any private class in here, right? Because if you are defining a class, at least the visibility of class should be, sorry, let me make it public again, right? When you are defining your class, at least this should be, the visibility of class should be at least within a project or within a namespace at least. We're getting it, right? If that is not the case, then there is the whole theme of class is missing there, right? That's why we don't go for private.
Okay.
Right, Monica?
Mm-hmm.
Perfect. Okay, good. So now, yeah. So that's about your class. Now let's go to the members, which is class member. Now we know that members, when we talk about members, we are referring to two things: variables and methods. Right? Both are methods or functions. Right? Both are class members. So for class members, we have all access modifiers. So maybe let's talk about private first, right? And then let me talk about public, or before public, let me talk about maybe internal, right? And then we'll talk about protect, right? All four, your private, internal, public, protect, all four access modifiers are applied to class members, right? Now let's start with the first one called private. Now private, right, will allow you to access this member only within class, within current class, not even assembly. right? Only within class, that's it. So let's see that. So in my class one, let me create two variables, sorry, two members, private, let's say integer amount, right, is equal to some amount, right? And what I'm going to do, I'm going to create one method called private void, let's say get data is my method name, is my private. So let me create some other method just for, let's say, void let's say void test method. I'll just for testing, because if I have to check what is within, right, within in the sense I should be able to access these things in my current class. Now, perfect. So now here we created one variable amount which is private, and one variable called get data which is private. Now when I say within class, which means I'll be able to call this amount within class any of the method and get data any of, which means this is something which I can access private. That's it. Visibility is done. Now when I go out of this class, I created one object, right? So when I go and see obj dot, you see, I'm not able to see any of the variable or any of the method, which means when you define a variable or a method private, right, the accessibility of this will be restricted to only within class. It will not even go across assembly, sorry, within assembly, and now across assembly we don't even have to talk, right, because within assembly itself it is not able to. Now, so by default, right, this is a default access modifier you have. If you don't define any access modifier for a method, then it is a default private, right, which we will not be able to access anywhere as such. Only within class it is possible. That's your default. That's your private. Now let's go to the internal. Now what is internal? The meaning is same. Internal again gives you visibility within assembly, right, within assembly. Now let's make this internal, and let's make this method internal, right? Now when I make this variable and method internal, yeah, still I'll be able to call it within class. It's always true. When I go to program here, see, when I say obj dot, now my visibility started. Amount I'm able to see, and also get data. So let's say amount, I'll check some amount, and obj dot get data, you can see. So both the things I'm able to access. Still I'll not be able to access my test method, you can see. Why? Because I've just created a test method without any access modifier, and it will be private. I'm just using this method to see visibility of these things with different access modifiers within the class. Within the class, everything can be accessible. That's one thing to keep in mind, right? So here, yeah, I'm able to access my amount and get data within assembly. Now let's check what is across assembly. When I say internal, it is only within assembly, but let's check it. When I say obj1 dot, see, I'm still not able to access my variables and methods. That's the cache here, right? That is your internal. So let's go to the next one called public. Now public, the meaning is same again, everywhere, right? So let's make these variables public here, public here too. Now, yes, when I make it public, first thing, yes, I can still access within the class, across my classes within the same assembly or same project, as I am able to, and across my assemblies, which is projects. If you want, I can see it. See, I'm able to now access amount, and I'll be able to access my, that's your public, where you're actually building the visibility of a variable and a method within the assembly and even across the assemblies. That's the public. So if you want to make any feature available across, within or across, make it public. And if you feel that okay, this should be used only within my assembly or within my project, make it internal. Or if you feel it should be used only within class, then make it private. That's your 3 access modifiers called private, internal, public, and protected. Right? Now let's go to the last one, which is very peculiar and kind of important one we normally use. Protected. What is protected? Protected members, and this protected is used for variables or methods here. So when you define a member protected, then that member, which is a variable or method, can be accessed only in connected classes. That's it. Now, you may get question, what is connected class? Connected class are like, for example, like inherited classes, kind of. We are going to understand the inheritance in a detailed way in our OOPS. But yes, let's see how these variables are used across. So first, let's make it protected. So I'm gonna make this protected and variable protected. Now see, as soon as I change visibility, right, now it started giving errors. Why? First step, go to program. Now you can see I will not be able to access protected variables in the same project without connecting to this class. Now connecting to this class is nothing but inheriting this class. What is inheriting? So I have my program. What I want to do, so in order to inherit, we will be using something called resolution operator, and I'll say class 1. Now this is called as an inheritance. Don't worry, we are going to actually understand the inheritance and other steps in detailed way in our next topic called OOPS. Okay, so now you can see here, I am connecting this class called trust. See, when you are actually connecting now, what will happen? Now class 1 is parent of program, which means whatever are there in class 1, I will be able to access in my program, except private. See, I don't have to create an object. See, through object, even now through object, you will not be able to call your variables here. And also, this is static method, if you can see, right? So let me create a separate method called void check status, some method, and here you can see I'll be able to call it. How? Let's say amount. You can see I'm able to directly call amount and also get data. See, this is how. Why? Because this class is now parent of program, which is like this variable and get data are like created in a same class kind of, right? Which means you are connecting 2 classes. This is something which is called as a related class, and I'm not be able to access through object. This is called as your connected class, and protected variables can be accessed only in a connected class. Now when I say connected, right, there is no boundaries for it. I can connect this class within the same project or across projects. You can see when I go to across project, which is my assembly 2, I can also create class 1 here, see, because end of the day class 1 is public. Again, even this matters. If class 1 is internal, that's it, done. Scope is denied. As my class 1 is public, I can access this class 1, right, which is a public here, which means now my program at AM2 second assembly is connected now. So what I can do, I can use it directly. So let's say void something, get energy, some method, and you can see I can directly call this method as if it is in the same class, but I won't be able to access it through object. This is called as your protected variable. Very strong, very powerful access modifier which allows you to access only through concrete classes, that too directly. Not there is no object of funda here. It's only through your objects. This is how we normally generate prototype. These are the complete set of access modifiers and the visibility how we create right across to access class, to access class members, to restrict class, and to restrict class members. So this is how we normally these are the actual access modifiers we use. So any questions across, guys? Yeah, clear with this? Perfect. So now this is about access modifiers and the usage. Now we are going to go to the next one called oops. Anyways, I hope I've already copied the assignment stuff, and I hope you guys can start looking at it. Now oops. So today let's understand the what is oops and why do we need it, and different oops patterns, right? And tomorrow we are going to start with the oop pattern, and we'll see oops in with different use cases. And understand this oops, guys, not just as a oops in .NET. You can apply this oops which you are going to learn now anywhere you want. It can be .NET, it can be Java, it can be even in cloud computing, it can be Salesforce, it can be Microsoft Dynamics, everywhere. The concept is same. We are going to see the use case in that way, right? Now, so here, so the first step, what is oops? Oops is nothing but your object-oriented programming system, right? So we have another word called OL. What is this? This is your object-oriented language, right? Now, what is the difference between oops and OL? What is the difference between object-oriented programming system and object-oriented maybe programming language, right? See, object-oriented programming language is a platform to write object-oriented programming system templates, right? So you can write object-oriented programming only if your language is supporting object-oriented language. As .NET is a pure object-oriented language, right? We can write any type of OOP program, right? So that's the difference. Never ever get confused. Your object-oriented programming language is just a platform, right? Which means that is compatible to write any object-oriented program, right? See, when we say object-oriented program, it's simple. Object-oriented, which means your platform is capable of providing you or allowing you to create a class, right? A platform is allowing you to create an object of that class. A program is allowing you to relate the classes. Now these steps, right, which we normally call is your object-oriented language. Simple. Okay. So our .NET is a pure object-oriented language. So when we talk about the previous softwares which we have before .NET, like VB or latest version VB6 or ASP, right, or your VC++ or so on, which are like Microsoft softwares, right? They were not object-oriented, pure object-oriented programming languages. Anyways, your VB6 and ASP were not at all object-oriented, right? They are structural-oriented programming language, right? So here, but .NET is completely thorough. So which means I can write any type of object-oriented programming system using my .NET. Simple as that. And the main theme behind object-oriented programming system, which is OOPS, is simple reusability, nothing else. Right? How best we can actually use one simple method defined in one class. Right? Definitely. Let's see. Always redundant code will always is always costly. Right? Always. Right? So when we write a redundant code, let's say same method, same logic, you are writing in 10 different places, right? And you're calling it. What will happen? Tomorrow, if you want to maintain that project, a small change you'll have to change across 10 different methods or 10 different files, right? And if anything goes wrong, if one method is missing, then your complete product may go down. We never know, right? So reusability or centric based programming or abstract model, program design or architecture is always the best one, right? And your object orientedness will give you a complete support of a abstract model design in .NET, right? And there are two basic entities which we always need for object oriented programming: one, class, and object. Everything is played through these two, right? Just a class, a programming language which enables us to use a class and object is your object-oriented programming language. Simple. Okay. And when we talk about OOPS are like, it's not a concept. Basically, when we talk about OOPS, right, it's not a concept. It's a pattern we normally call. It's normally pattern on some rules which you follow to see. Throughout our object-oriented programming system, you will never see any new concepts. You will see one class on object, one class on object. That's it, nothing else. Or maybe class or interface and object. That's what you're gonna see. Fine, it's just a pattern how to write a program. Now, there are 4 different OOP patterns we have. First one is your inheritance. Second, you have polymorphism. Third, you have abstraction. Right here itself, you're going to see interface too. And the 4th one is your encapsulation. Right? So these are the 4 different OOP patterns we have: inheritance, polymorphism, abstraction, and during understanding abstractions, it is not OR, guys. It is not OR. No, you will never call abstraction as interface. These are 2 different things, right? But what I'm saying, during abstraction, we also learn interfaces, right? And then you have encapsulation. So your interface creation is not a OOP pattern, but your abstraction is a OOP pattern. Right? Inheritance, polymorphism, abstraction, and encapsulation. These are the 4 different concepts, OOP concepts you have, which you can use. And all see these rules. There is a common understanding or common rule across these 4: reusability, code reusability. Right? How best we can use this reusability? Even now, right? It was actually introduced, decades before when C++ was there. But even now, these 4 patterns are based for each and every design and each and every architectural decisions. So that's why these are like, very important and strong concepts we have to learn even before understanding any other design patterns. Fine. That's about your OOPS concept. Now here we're going to anyway start with inheritance. We'll take everything with an example of or a use case, and we'll try to build deeper level of concepts here. Right? So that we're going to start from tomorrow. OOPS. Right? We are almost getting towards it, guys. We have 4 big concepts. OOPS anyways we're going to take up, and then we have a multi-threading, exception handling, and collections. So these are the things which we have as part of the C#. Right? So let's meet up in tomorrow's class, guys, and we'll actually start with inheritance. Very important, please don't miss, right? The class of OOPS. Okay. So under assignments folder, which is October 15 batch, you have C# class. Don't worry about all others. I've just copied every assignment here. Don't worry. We just have to start C# class, and as soon as anyone are done with 1, 2, 3, 4, 5, any number of tasks in this, right? You may be able to do first for 7 tasks on the max mainly, right? So please, you can actually show it to me in tomorrow's class or day after tomorrow, whenever you want, right? So please start off, guys. So the assignments are important and they are mandatory as such. Fine. Okay then, guys. So let's meet up in tomorrow's class. Thanks for joining.